Okay guys, this is the problem solving video for Unit 1 in companion with the notes video I also have. So I'm going to be giving you 5 problems on the limits topic in AP Calculus, and then I'd recommend that you pause and solve them on your own before coming and checking your work with me. Okay, so for this first problem here, we're given a graph and we're asked 3 things about the graph. So for part A, we're asked to find the limit of f of x as x approaches 2. So what we're going to do now is we're going to look at what's going on in the graph of f of x as it approaches 2 from both sides. So we're going to start with the left. As x approaches negative 2 from the left, it looks like it's approaching this value here, right? It makes sense. And that value looks to be about 12. Oh, sorry. It looks to be about 12. And then when I go from the other direction, the value also seems to be approaching this point here. So from both directions, it seems to be approaching this point of 12. So that lets me say the limit as x approaches 2 of f of x is just 12. If you said 13 or 11 or whatever, that's fine. And then for part B, we're asked to find f of 2. And now notice that while the limit is defined, at f of 2, there's a hole, right? There's a hole. There is no value. F of 2 is undefined. Undefined, right? But now what's important about that is that you note that even though the value is undefined, you can still have a limit. The actual point doesn't have to be there for the limit at that point to exist. Okay? And then for part C, the limit as x approaches infinity of f of x, and then we look at what's going on when x approaches infinity. It's going up and up and up and up forever. It's never slowing down. It's never going to stop. So what that means is that it's going to go on and on to infinity. As x approaches infinity, the function is going to approach infinity as well. So the limit as x approaches infinity of f of x is infinity. Okay, so that was question number 1. Okay, so this is question 2. We're asked to find this limit here. And the first thing you notice right away is that you can't directly plug in negative 3 into here, because you're going to get a 0 in the denominator with the negative 3 plus 3. And, you can't divide by 0, so we're going to have to figure out a different way. And then when you see this square root, a square root minus something up here, the first thing that should have came to your mind was, oh, I should multiply by the conjugate. And so that's exactly what we're going to do. We're going to take our limit as x approaches negative 3 of the square root of 2x plus 22 minus 4 over x plus 3. And then we're going to multiply it by its conjugate. And remember, the conjugate is just switching out the positive here, or the negative. We're going to switch it out for a positive. And then I'm basically, since I'm multiplying the top and the bottom by the same thing, it's basically the same as multiplying it by 1, right? I'm not actually changing the value of the function at all. So this is equal to, and then now I can just, I have a minus b times a plus b, and then you should recognize that as the difference of two squares. So that's going to be the square root of 2x plus 22 squared minus 4 squared. And then in the denominator, I'm not going to expand this out yet. Don't expand something out because it looks like it's going to be a little bit of a pain. So don't expand it unless you see it to be absolutely necessary, because there are chances that you're probably not going to ever need to expand it at all. So this is, we can just expand this. The square root is gonna cancel with the squared, and we're just gonna get 2x plus 22 minus 4. And then I'm still not expanding it out because I still don't see a need to expand it yet. Okay, and I'm gonna switch to a different color because I'm getting bored. So And then I can combine this, and I'm going to say, oh, that should not be 4 actually, that should be 16. Because we squared the 4, right? Because a squared minus b squared. So the limit as x approaches negative 3 of 2x plus 6 over x plus 3 times this thing. And hopefully, when I simplify that, you should see where this is going to go, what my next step is going to be. If you don't, that's okay, but the next step is going to be factoring out a 2 from the numerator. And that did something really, really wonderful for our limit here. What that did is, now look, I have an x plus 3 on the top and an x plus 3 on the bottom. And I can say, okay, y'all are gone. And the reason that's so awesome is because, remember, at the very original limit, the negative 3 was combining with the 3 to make 0. And that was what was giving us all that trouble. So now we got the troublesome x plus 3 out of the way. And I'm assuming that now, when we evaluate our limit, it's going to be a lot easier. So let's see what's going to happen now. I'm going to have 2 over this stuff. And yeah, now look, you can just simply plug in negative 3 and you're going to get an answer. So my answer is going to be 2 over square root of 16 plus 4, which is 2 over 8, which is 1/4. And something else I want to stress is that notice how I kept writing the limit as x approaches negative 3 in every single step until we substituted the negative 3 in. That's really, really important. You want to keep this limit part so that the people who are looking at your work, they know that you're talking about a limit and you're not just talking about the function. Okay, so now if I'm just going to summarize my answer, I'm going to say the limit as x approaches negative 3 of my original thing, 2x plus 22 minus 4 over x plus 3, we said, okay, that's equal to 1/4. And we are done with question 2. Okay, so now we're looking at question 3, and then it's another limit. And the thing that's special about this one is the absolute value up here. So when you see an absolute value, that means what's going to happen is we're going to split it into 2 different limits. Okay, so the first limit is going to be when the numerator is negative, right? Because the absolute values can be, it can be, the inside can be either negative or positive. We don't really know. So we're just going to try both. And then, right, so one of them is when the limit, this numerator here is negative, and the other one is when the absolute value is positive. So I'm going to keep it as 2x minus 5 over 2x minus 5. And then the great thing about both of these limits is that they're really easy to evaluate because the 2x minus 5s, in both situations, they just cancel out. So this is going to be a negative 1, and this is going to be a positive 1. And then also something else is that the numerator, it's going to be negative if x is less than 5/2, because when x is less than 5/2, 2x minus 5 is negative. So it's negative 1 when x is less than 5/2. And then on the other hand, when x is greater than 5/2, we're going to have this situation up here where the numerator is positive. So x is greater than 5/2. And then now let's look at what's going on. So when we had a negative here, we get one answer. When we have a positive, we get another answer. And then the answers don't really meet up at all, right? So what that means is that the limit does not exist, because when we're approaching it from both directions, we're getting different answers. There's no one single number that it's approaching. So what we'd say is that we'd say, well, the limit as x approaches 5/2 of the absolute value does not exist because we got different numbers. So that was question 3. Okay, so for question 4, we're given this expression up here, and we're asked to find the limit of f of x as x approaches first positive infinity and then negative infinity. So first, when you're given this kind of expression, you want to look at the coefficients. And then here we have the highest power is 3, and the highest power is 6, right? And then remember, the square root is just going to turn the 6 into a 3. If you don't know what I mean by that, I mean I can rewrite this as 8 plus x minus 4x cubed, and I can just factor out the 7x to the 6th completely. Or just factor out the 7x to the 6th. And then I can just pull it out of the square root. And then when I pull it out of the square root completely, I have equal powers. And when you have equal powers, to find the limit, you want to look at the coefficients. Here we have -4, here we have 7. And then the reason I didn't put the limit for this is because I'm not actually evaluating the limit just yet. I'm just simplifying, or not really simplifying, but I'm manipulating the equation to better fit my needs. So now let's work on the actual limit. So for part A, we want to find the limit as x approaches infinity of f of x. And then, so remember I said, we want to look at the coefficients. Here, it's -4, and here it's square root of 7. So the limit is just going to be -4 over square root of 7. And then for part B, negative infinity. Now take a minute and think about, is there anything different that's going on with the negative infinity versus the positive infinity? Well, let's look at this original expression here before we pulled out the 7x to the 6th. Well, looking at this original expression here, if we plugged in a negative infinity, right, it would be to an odd power, sorry. So this would be a really big negative number. While here, this is raised to an even power, so it's going to be a positive number, because anything raised to an even power is positive. So we would have had a negative power times a negative number, which is a positive. We would have had a positive divided by a positive, which is just going to be a positive. While when we had a positive infinity, we would have had a negative divided by a positive, which is what gives us the negative here. Basically what I'm saying is that this limit is just going to be a +4 over square root of 7, because when you plug in negative infinity, this would have become a positive number at the top, and this would have become and also a positive number at the top. So a positive over a positive gets us our positive limit. And that's question 3. Okay, so now we're looking at question 5, and then we're asked to evaluate this limit by the squeeze theorem. So when you have a question about the squeeze theorem, the first step is finding a part of the limit that's bounded, that doesn't go on forever. And then in our case, the part of the limit is sine, because sine of anything is always going to be between -1 and 1, right? So sine of no matter what x is, the value that it's going to output is going to be between -1 and 1. Right, I'm just going to give myself a bit more space. And so now that we've gotten this inequality set up, the only thing that's left is to plug in the different parts of our function. So I can multiply everything here by x to the 4th. So then I'm going to get negative x to the 4th is less than x to the 4th times sine of pi over x, which is less than x to the 4th, right? So now this is looking one step closer to our answer, but here they're asking for a limit. So I'm going to take the limit as x approaches 0 of this is going to be less than the limit as x approaches 0 of this, which is less than the limit as x approaches 0 of this. Okay, now this is what we're trying to find. We don't know what this is. However, we know the two limits on the end. So let's evaluate that. the limit as x approaches 0 of negative x to the fourth, just plug it in, we're going to get 0. And then the limit on the right, just plug in 0 again, you're going to get 0. So 0 is less than the limit as x approaches 0 of x to the fourth sine of pi over x, which is less than 0. And actually, before I go further, I've noticed a big mistake I made here. This should be less than or equal to, because sine could be -1, sine could be 1, so these all should be less than or equal to. So anyways, now we have this, and then we've this is what the squeeze theorem really is. We're squeezing it between two different functions, and we've found that 0 is less than, this is less than 0. Therefore, we've determined that if a number is less than 0 and greater than 0, it must be 0. So this limit is 0 by the squeeze theorem. Okay, so that was 5 problems that relate to the limits unit in AP Calculus. Hopefully you found this helpful in some way, shape, or form, and I will see you later, I guess.